So the exercise, this is the same exercise we did last week related to energy change calculation. Till 18 are the multiple choice question, and then from 19 onwards, we'll solve the structure questions. So this is the second last ethene undergo a complete combustion. Some bond energies are given. What is that? And the energy change for this reaction is minus 1408. We need, what is the bond energy for CO? So reactant side is a bond breaking side, and the product side is a bond forming side. So 1, 2, 3, 4. So bond breaking, there will be 4 CH. Plus carbon double bonded with carbon, carbon double bonded with carbon is there, only one of them. And then OC, sorry, oxygen double bond is there, and how many of them? Because one molecule is having one double bond, so 3 molecules will have 3 double bonds. When we substitute the values, so it will be 4 into CH, which is 412, plus carbon-carbon double bond 612, plus 3 times oxygen double bond 496. What's the answer for this? 412 times 4. This will be 1648 plus 612 plus 496 times 3. The final answer is 3748. Okay. The final answer is 3748. That's a bond breaking energy. Now bond forming energy, because the product side is a bond forming. So in one molecule of a carbon dioxide, there are 2 CO bonds. So in one, and we don't know, that is what we need. We need the bond energy for CO. If one I'm saying X, this is also X. So in one molecule, there are 2 unknown, like 2 CO bond. In 2 molecules, there will be 4 CO bond, because like this is one molecule and this one will be another molecule. So how many each molecule, each bond, if unknown is there, X we say, so the total will be 4X. Plus in one water molecule, there are 2 OH bonds. In one water molecule, there are 2 OH or HO bonds are there. But because there are 2 water molecules, so how many OH bonds will be there? 4 OH bonds. And each OH bond, this is 4X, and each OH bond is how much? It is 463. 463. So 463 into 4. 463 into 4. What's the answer for 463 into 4? 463 times 4. 1852. So we have the bond breaking energy. We have the bond breaking energy and we have the bond forming energy. And we have the, but bond forming energy, the CO bond is unknown, so we said X. And the energy change is this value. This is the energy change. So we'll use the formula that bond breaking energy, because this time we need the bond energy. So we use the formula that the enthalpy, the bond breaking energy minus the bond forming energy is equals to enthalpy change. The bond breaking energy is how much? It is 3748. Minus the bond forming energy is how much? It is 4X plus 1852. That is a bond forming energy. And what is the energy change for this reaction? The energy change for this reaction is minus 1408. That is the energy change which happen or occur when this reaction take place. Now we simplify, like we just have to solve as a mathematical equation. So this will be, this is positive 3748, it will move other side. So it will become negative, so minus 1408 minus 3748. And this negative is multiplied with 4, so it will be minus 4x and minus 1852. This minus 1852 also move other side, will become plus. So minus 4x is equals to minus 1408 minus 3748 plus 1852. What is the result on the right hand side when you solve? Minus 1408 minus 3748 and plus 1852. What's the answer for this? So minus 3304. That is equals to minus 4x. We need x only. X is like the CO bond energy. So minus 3304 divided by minus 4x. So 3304 divided by 4. What's the final answer? $826. So 826, so which matches with option C. So C is the right answer. In this question, we need a bond energy that was unknown. So that's why we took that as X. So the formula remained the same. The bond breaking energy minus the bond forming energy equals to energy change. Is it clear, this question? Anyone having a doubt? Moving on to the next question, a similar question is there. A reaction between hydrogen and oxygen releases, whenever energy is released, this means this is the enthalpy change. So this enthalpy change is, it is, even though it is written 486, but because the energy is released, it means the reaction is exothermic. So the enthalpy change must be negative. So it should be minus 486. The bond energy for hydrogen is there, and oxygen is there. We need oxygen. So first we have a bond breaking side, and then we have a bond forming side. Bond breaking, hydrogen, and two of them, like one molecule contain a hydrogen single bond. There are two molecules, plus oxygen double bonded with oxygen is unknown. And bond forming, because H2O means HONH. And how many water molecules are there? Two water molecules. So it will be HONH. So total number of the bonds, because HOH, so how many one molecule contain two OH bond. So two molecules contain 4 OH bond. So this will be 4 OH or 4 HO. It's the same thing. We substitute the value for bond breaking. So it will be 2. Hydrogen is 436. And oxygen is unknown. That is what we need. Oxygen double bond. So 436 multiplied by 2, that will be 872. 872 plus X, and this will be 4 into 464. 4 multiplied by 464. What's the answer? 464 times 4. 1856. So this is a bond forming energy. Now, how to solve this question? We'll use the same formula, that bond breaking energy minus bond forming energy equals to energy change. And the energy change is minus 486. So bond breaking minus bond forming is equals to energy change. Bond breaking is 872 plus X minus the bond forming energy is 1856. And what is the total energy released? That is 486. So minus 486. Now we just need value for X. So all the things will move other side. So X is equals to minus 486. This is negative. It is that other side. It will be positive. So it will be plus 1856. 872 is positive. Other side will be negative. So minus 872. So when you simplify minus 486 plus 1856 and minus 872, what's the final answer? For the value of X or the unknown? Minus 486 plus 1856 minus 872. What's the final answer? 498. So 498, so which matches with option C. So C is the right answer. Is it clear, this question? So idea is the bond breaking energy minus bond forming is equals to enthalpy change. Question 19, which is a structure question. The part of a diagram, energy profile diagram is shown here. The reaction is exothermic. So if the reaction is exothermic, what should be the energy profile diagram? Remember that in exothermic reactions, the reactants have high energy and the product is having low energy. So if we need the position of a product, where we make the position of a product, so it should be bottom. And it is C2H4Br2. So first, the position of a product, because exothermic reactions, reactants have high energy and the product is having low energy. Then show an arrow, activation energy. So activation energy is a minimum possible energy at which the reaction start. So activation energy arrow should always point upward, even it's an endothermic reaction or exothermic reaction, and label that as A. So you'll write this as A. And arrow to show the energy diagram, energy change for this reaction. So energy change, because it's an exothermic reaction, so energy change diagram, the arrow should be downward, which is energy change or enthalpy change. So this is delta H and this one is activation. This is an energy profile diagram for all the exothermic reaction. Any exothermic reaction, this will always be an energy profile diagram. Reactants have high energy, product is having low energy. But what if the same question was there and they say that the reaction is endothermic? Like this one is already mentioned, it is an exothermic, but what if they said that the reaction is endo? Then the reactant should have low energy and the product will have high energy. And then the activation energy, the arrow pointing for activation energy upward, and for enthalpy change also upward. So same idea, but the positions of the reactant in products are different in energy profile diagram for exo and for endothermic. The next question, like the second part of the question, the chemical equation for a reaction can be represented by this, like the bonds are shown here. and the bond energies. Use the bond energy to calculate the energy change. Whenever a question is there, energy change, so it means you need delta H. So energy needed to break the bonds. So whenever they ask for bond, like bond breaking side, so you always take the reactant side as a bond breaking. So reactant side is always a bond breaking side. The product side is a bond forming side, or energy is released when the bonds are formed and energy is needed to break the bonds. So we separate the bond which we are breaking from the reactant side. So there is a carbon-carbon double bond is there. So there's a carbon-carbon double bond in the bond breaking side, which is 610. Then there is carbon hydrogen, and how many of them? 1, 2, 3, 4. So carbon hydrogen bonds are there, 4 of them. So it will be 4 into 410. Then there is Br-Br bonds, bromine-bromine. How many of them? 190. And we will add all of them, like 410 times 4 plus 610 plus 190. The sum will give us the bond breaking energy. Which is 2440. That's a bond breaking energy. Then the product side is a bond forming. How many bonds are formed? There is 1, 2, 3, 4. So 4 CH bonds are there. So 4 times CH, 1, 2, 3, 4. CH is 410, so 410. Then this carbon-carbon single bond is there. Carbon-carbon single bond is 350. Then this carbon-bromine bond, CBr bond. How many of them? 2 of them. So it will be 2 multiplied by carbon and bromine bond, 290. So 290 times 2 plus 350 plus 4 into 410. When we simplify, this will give us a bond forming energy or energy release when the bonds are formed, which is 2570. So without calculation, which type of reaction is this? Exo or endo? The bond breaking energy is 2440 and bond forming energy is 2570. Which kind of reaction is this? Exothermic or endothermic? What is the type of a reaction? Endo or overall reaction? Because whenever a chemical reaction occurs, some of the energy is absorbed, some energy released. We check which is more. Because for this one, the bond forming energy is more. That's why it will overall it will be exothermic. If the bond forming is more, overall exothermic. If bond breaking is more, overall it will be endothermic. The bond breaking energy is 2440. Bond energy release is 2570. Then what is the energy change? Energy change means enthalpy change. What is the formula for enthalpy change? The formula for enthalpy change is a bond breaking minus bond forming. So bond breaking was how much? 2440 minus bond forming 2570. When you simplify, you get the energy change for this reaction, which is about minus 130 kilojoule per mole. Is it clear, this question? Anyone having a doubt related to this one? Moving on to the next question. The equation for reaction can be represented. A similar question is there. We need the energy change. You just follow the step, but important thing is you should identify the bonds correctly. So always the reactant side is a bond breaking side. The product side is a bond forming side. Bond breaking. So 1, 2, 3, 4, 5, 6. So there are 6 CH. Then there is carbon-carbon single bond. So 6 CH, so it will be 6 into CH bond energy is 410. So 6 into 410. Then there is carbon single bond is there. 350. Then there is chlorine bond. 240. So this whole is a bond breaking site. So the total when we add 6 into 410, 3050. So that's right, 3050, that's a bond breaking. Then the bond forming, 1, 2, 3, 4, 5. So there are 5 CH bonds. So 5 into 410. Carbon-carbon single bond is there. 350. Carbon-chlorine bond. 340. And hydrogen chloride bond, HCl bond, 430. So this is how much? 3170. Okay. So 3170 is a bond forming. We need the energy change because so the bond breaking was this was 3050. The bond forming energy was 3170. First, which reaction is this? Exo or endo? What is the type of a reaction? Endothermic or exothermic? That's right, it will be exothermic. Overall reaction will be exothermic because why the overall reaction is exothermic? Because the bond forming energy is more. When bond forming energy is more, the reaction is exothermic. And how much is the energy change? So energy change is the bond breaking minus bond forming. Bond breaking is 3050 minus bond forming is 3170. So we get minus 120. Minus 120 shows that this reaction is exothermic. When this reaction happen or occur, it releases the energy to the surrounding. So whenever a chemical reaction occur, the energy is absorbed, energy is released. We check the overall what happened. So same way, for this question, we'll have a bond breaking, the bonds which we are breaking, 1, 2, 3, 4. So 4 CH bonds are there, plus 1 and 2 Cl bonds are there, carbon and chlorine bond, plus carbon and carbon single bond. So it will be 4 and CH bonds are there, 410 plus 2 carbon and carbon chlorine, 340 plus carbon carbon, 350. When we simplify this, we get bond at 2670. So 2670 is a bond breaking. Bond forming, the product side is always a bond forming. This is a bond forming side, this one is a bond breaking. So we have 1, 2, 3 carbon and hydrogen bonds are there, plus carbon carbon double bond, plus hydrogen chloride bond. So when we simplify, this will be 2610. 2610. So this is because the reactant side is a bond breaking, the product side is a bond forming. So bond breaking energy, when we calculated, it was 2670. But bond forming energy is how much? 2610. So what will be the type of the reaction this time? Is it endo or exo overall? The bond breaking 2670. The bond forming is 2610. So overall, this reaction will be endothermic because the bond breaking is more. And how much energy change will occur? So we just take a difference of the two, 2670 minus 2610. So this will be 600. This will be 60 plus 60. And deduce whether the energy change of this reaction is exo or endo. So it will be endothermic, and reason is that because the bond breaking energy, what is the reason for that? The bond breaking energy is more than bond forming energy. You will write in words, I'm writing in short, but you will write in words that the bond breaking energy is more than bond forming.